This is Shakil Ahmed. Welcome to the SPSS learning tutorial. In today's tutorial, we discuss some non-parametric tests. Previously, we learned the parametric test. The parametric tests were based on certain assumptions like normality, and we assumed that the data were on a ratio scale and there is no outlier. But certain assumptions may not fulfill in practical situations when we come to the practical data. So in such situations we move toward the non-parametric statistic or non-parametric tests. The non-parametric tests are based on some lighter assumptions like the data should be on interval scale and the data is uh, asymmetric about mean, so we use median instead of mean such for such type of data. As there are influential variable, so we test for median rather than mean. So we first start with binomial test. The binomial test is used to compare the proportion of a population to a certain value. So for conducting test of proportion, we go to the option of non-parametric test and then go to the legacy dialog and then select the binomial test. Which variable we want to test, for which variable we are conducting to test. For example, we are conducting to test that the smokers in the population is equal to 60% or 70%. Then we need to select the exact p-value and then continue and then OK. This is the binomial test. Do you smoke? This is group 1 and this is group 2. The proportion of smokers is 0.7, which is not statistically significant. The p value is 0.228. The alternative hypothesis state that the proportion of cases in the first group is less than 0.7. So the alternative hypothesis is accepted, and the null hypothesis is accepted as the p value is 0.228. Here we performed exactly significant for one tailed test, that the null hypothesis was the proportion is greater than or equal to 0.7. So the hypothesis is accepted as the p value was 0.228. And now we will move to the run test. The run test is used to check whether the data is random or not. A run test is defined as a series of consecutive positive or negative values. Basically, a run test is usually conducted before starting of every parametric test. In most of the parametric tests, we assume that the data is randomly and normally distributed. It means that we assume there is no autocorrelation in the data. So for this purpose we use a run test. In run test, the null hypothesis is that the sequence was produced in a random manner, means the data is random, and the alternative hypothesis states that the data is not random. The test statistic is the z statistic, where r is the number of runs and r bar is the expected number of runs, and SR is the standard deviation of the number of runs. And this test statistic is used if the absolute z is greater than z1 minus alpha by 2, then that means we are conducting a two-sided z test. So we start again with the analysis option, and then go to the non-parametric test and then LJC, and then select the runs, and we check the student score is random or not. So go to the option of exact, and you can select the exact option and then continue, and you can opt for median as the cut point or mean as the cut point. As the data is asymmetric, we should tick on the option of median, and then click on OK. You will see the asymptotic significance for two tail and exact significance for two tail, which is uh, insignificant. So this means that the data is random. Our null hypothesis was that the data is random, and the p-value suggests that the data is random. So this was the run test. In the next videos we will learn more on non-parametric tests. Thank you for watching the video and subscribing the channel.